Hello everyone and welcome to my channel. Let's understand the chord properties of circle. First property, theorem 1. Equal chords of a circle subtend equal angles at the center. Means, in this picture, in the circle, A, B and C, D are equal chords. It is given that the chords are equal and we have to prove that it will subtend equal angles at the center O. That is, angle AOB is equal to angle COD. So let's understand this theorem. Children, how you have to prove any theorem? First, you have to write down all things in a sequence wise, like the statement of theorem, then what is given to prove means what you have to prove, and then the process, that is proof. So we start this theorem. It's given a circle in which chord AB is equal to chord CD. To prove angle AOB is equal to angle COD. Now the process. In triangle AOB and triangle COD, if you see properly, OA, OB, OC, OD, what are all these things? All these are radius of the given circle and all radius are equal. So OA is equal to OC, that is radius. OB is equal to OD, that is also radius. And AB is equal to CD, it is already given. So if you see, so by the SSS congruency condition, triangle AOB is congruent to triangle COD. Now as we know by CPCT, the corresponding parts of the congruent triangles, angle AOB is equal to angle COD, hence proved. Next theorem is the converse of this theorem. Means, suppose you have to prove if the angles subtended by two chords at the center of a circle are equal, then the chords are equal. So it is given that the angles are equal. Means angle AOB is equal to angle COD. Now what we have to prove? We have to prove that the given chords should be also equal. AB is equal to CD. So let's understand the converse of this theorem. Again, the process is same. You have to write down first given what the things are given, to prove what we have to prove, and during the solution only you have to congruent both triangles, triangle AOB and triangle COD. So if you see properly the picture, OA is equal to OC radius, OB is equal to OD radius, angle AOB is equal to angle COD, it is given. So by the condition of SAS congruency, it is congruent. So by CPCT, AB is equal to CD. Now let's understand the next important theorem of chord. The theorem is the perpendicular from the center of a circle to a chord bisects the chord. Means in this picture, AB is the given chord and OX is perpendicular to AB. And we have to prove XA is equal to XB. So let's understand the process. Given OX is perpendicular to AB, to prove XA is equal to XB. Here you have to add one more step, that is construction. To proving, we have to join OA and OB. So in the construction, write down join OA and OB. Now during the proving of this, we have to prove the triangle AOX and triangle BOX is congruent. So in right angle triangle OXA and OXB, we have OA is equal to OB, radius of the circle, OX is equal to OX, that is a common side, and angle OXA and OXB is equal to 90 degree. Then by RHS congruency, the given triangles are congruent, hence XA is equal to XB. Next. The next theorem is again the converse of this theorem, children. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Means here it is mentioned that M is the midpoint of the chord AB. And we have to prove OM is perpendicular to AB. So again you have to write down the steps given to prove and construction. In the construction, join OA and OB. Now prove this triangle AOM and BOM is congruent to each other by the condition of SSS, because radius OA, OB are equal, OM is a common side and MA is equal to MB, it is already. So when we prove that these two triangles are congruent to each other, then by CPCT, angle OMA is equal to angle OMB, and this angle form a linear pair angle, means 180 degree. So if you add these two angles, it should be 180 degree, and both angles are equal. So each angle is 90 degree. And if the angle is 90 degree, it means this line is a perpendicular line. So OM is perpendicular to AB. Theorem number 5. Equal chords of a circle are equidistant from the center. Means two chords are given in this circle, that is chord AB and chord CD, and both are equal. We have to prove that the distance of these chords from the center is also equal. So what is the distance from the center? It is OL and OM. So we have to prove OL is equal to OM. Again, we have to write the construction step. We have to join the lines OA and OC, that is radius of the circle. During the proving of this theorem, we know that the perpendicular from the center of a circle to a chord bisect the chord. Okay, so by this, AL is half of AB. L is the midpoint of the chord AB. Similarly, M is the midpoint of chord CD. So CM is equal to half of CD. And AB is equal to CD. It is already mentioned that the both chords are equal. It means AL is also equal to CM. Now, in the right triangle OLA and OMC, if you look properly, again we have to prove these two triangles congruent to each other. So AL is equal to CM. OA is equal to OC, that is radius of the circle. Then again by the RHS congruency, because angle L and angle M is 90 degree. So triangle OLA is congruent to triangle OMC. So OL is equal to OM. Hence AB and CD are equidistant from the center O. Again, the next theorem is the converse of this theorem, like the chords of a circle which are equidistant from the center are equal. It means AB and CD are the two chords of a circle. OL is perpendicular to AB and OM is perpendicular to CD, such that OL is equal to OM. It is given that OL is equal to OM, and we have to prove that the given chords are equal. It means AB is equal to CD. Write down in a proper way given to prove, and in construction join OA and OC. Again, we have to prove the triangle ALO and triangle MCO are congruent to each other by the RHS congruency. As you prove this, it means AL is equal to CM. AL is half of AB and CM is half of CD. So AL is also AB by 2 and CM is CD by 2. So we can write AB by 2 is equal to CD by 2. That is AB is equal to CD. Thank you for watching.